Okay, everybody, we are in week 12, and the term paper, I'd like to have this in by Tuesday. So today's Thursday, just get it in by Tuesday. And let's go over the guidelines with you here briefly. So fall 2015 guidelines are the same. And I know Gary's been working on the experiment, getting the hydrogen truck up and running. So here's the summary. So just let me know where you did it, when you did it, what type of fuel is being used, and who you've talked to. Like, so for example, Gary's already talked to a couple of the technicians that built the hydrogen truck. Process description. So in the case of hydrogen, we're looking at an electrolysis system that we currently have. Talking about mass balance, important to look at the stoichiometry of hydrogen combustion. Energy balance, so if we're looking at the vehicle, how much energy is going in and what's the horsepower coming out. Chemistry is relatively simple. The other thing to keep in mind, though, with the hydrogen truck, for example, is it's going to run on either octane or hydrogen, and typically not both, at least not nicely. Product separation, purification. So in the case of hydrogen, obviously you're looking at coming from water with our hydrolysis system. Feedstock, product storage. The storage in the case of the hydrogen, it's sitting at 5,000 psi in the Kevlar tanks. The reactor type, batch or continuous. So with the hydrogen fueling station, the electrolysis is actually continuous, but then it's got three stages of storage. So you can think of that as being more or less batch. In the case of feedstock or handling, you've got a pump. Heating and cooling. The vehicle itself obviously has a radiator. In terms of separation and purification, the electrolysis that drives the hydrogen is that process. Computer, we got two. Actually, I think there are 3 or 4 separate computers. There's the gasoline, the hydrogen, and at least the turbocharger, and Paul mentioned a 4th one. Let me just see if I can find that. Let me see if I can. Okay, so the other point here is just to be quantitative in your description of your fuel system. So talk about the temperatures, talk about the pressures, staffing requirements. One thing that we're looking at for our waste to energy process. So even just today, Sean Doty, and I'm gonna dip into that really quick because this is totally relevant to what we're looking at. So staffing requirements, repair and maintenance issues. Oh, and I'll show you one thing here. I wanted to cover this briefly because we're looking at the term paper guidelines. So staffing requirements. So for example, this is a technology that we're looking at right now. It's a plastic waste to liquid fuel system. So here's a guy giving his TED talk showing that he can go from all this plastic waste into a fuel. This is typically a kerosene. You can see there's some guys doing this in Africa, and here's a much larger system. So what I'm not sure on in relation to our energy conversions, like what are the staffing requirements for this thing? It'd be nice to know, like, does someone have to run some valves, run the conveyor belt, can it run itself? Repair and maintenance. you're all over that on the hydrogen truck. We know what the issue is there. Capital costs, you've gone into this. We just looked at the capital costs on this waste oil, and we just did the conversion. So the larger continuous system is 32 million yen, which is $300,000. So then you have to look and say, okay, what's going to be the payback on that? How much plastic do you have to pump through that thing to get your energy back? Operation and maintenance costs, what's the cost of electricity if that's what's running? Feedstock cost. Now this is where it gets a little bit tricky, because right now feedstock for waste, we actually pay to get rid of our plastics. So that what you need to do is the entrepreneurs say, hey, I will charge you less to get rid of your waste, and now you can make money sort of on both ends. Same thing with somebody, any kind of waste conversion. That's just kind of where we are with the economy right now. What the product value is. So again, is it more valuable to turn this into a solid commodity, or in this case into a fuel for burning? Put the pictures in there. I've asked for that already. Illustrations, schematics, diagrams, and then references. So that's it. And I haven't really heard, from Serenity or Jason on what their projects are, but I'll email them right now.
I don't know. Do you know what Sean's project is?
Hey, there he is. I don't.
Do you know what Sean's project is?